Okay, so we're gonna talk now about the ear that holds the hearing and balance senses. So we have three parts of our ear. So let's talk about these parts. External ear, middle ear, and internal ear, or the labyrinth. So the external ear goes all the way here. All this is external ear, right? And you have the auricle or pinna, which is this round structure that we can see. And you have the external acoustic meatus that goes through the bone, the temporal bone. The rest from middle to inner ear, internal ear, all this part inside the square is inside the temporal bone. Everything is inside the bone, okay? So what do you have in the middle ear? Tympanic membrane. Tympanic membrane is just a thin membrane that works like a drum. And that membrane is the eardrum, right? And the eardrum is connected to three little bones here. This is the malleus. Malleus means relates to hammer, okay? So it's that hammer shape of this bone. Then you have the incus here. Incus has the shape of an anvil. And the stapes, which is this one, looks like a stirrup. The stapes, so three little ossicles, okay? The stapes connect to the oval window, which is this part here. And here you have the round window. Okay, these are other drums that are going to vibrate. So everything is vibration, right? You vibrate here, it vibrates, it makes the three little ossicles connect together. They're connected together. Move, one moves the other, that moves the other. That knocks on the oval window. And then so everything here is air, and everything here is air filled. From in the inner ear, everything is filled with fluid, okay? So here are the bones again, the malleus, the incus, and the stapes. So oval window again, round window. So this is the cochlea. It looks like a little snail, right? These are the cochlear nerves and the vestibular nerve that make the vestibulocochlear nerve, remember, the cranial nerve. This is the vestibule. This is related to equilibrium already. This is related to static equilibrium. And this is related to equilibrium when there is acceleration, okay? One thing that is important here, middle ear, you have the, pharyngotympanic tube, which is this tube right here, okay? Where does this tube go? It goes all the way to your nose, to the back of your nose, in the nasopharynx, right? So why do you have this? This is just there because you see how this is all enclosed? So you need somehow to equalize the pressure from the air here with the pressure that is here. So the only opening you have so you can equalize these two pressure is your nasopharynx. So the air flows through here, right? That's why when you are in a situation where there is high pressure, you open your mouth and you feel like your ear goes back to normal because air is going through here and equalizing pressure in the middle ear to the external pressure, okay? When stapes hit on the oval window and the fluid moves here, the round window is just a way, like a compensation for that pressure that was exerted on it. When you have otitis media, you have an inflammation and accumulation of pus in this area here, okay? It can cause hearing loss in kids because depending on the pressure that the mucus is causing, it could rupture your eardrum. And then in the inner ear, we're going to talk about two main structures. One is the cochlea and the other is the labyrinth organ. So the whole structure in the internal ear is called labyrinth. The bony labyrinth is the bony structure that surrounds this organ. And then you have the membranous labyrinth, which is the tissue part that is inside the bony labyrinth. So it's a series of membrane sacs and ducts that are contained inside the bony labyrinth. They are filled with a substance called endolymph. Okay? So what are the structures in the membranous labyrinth that we need to know here? This is the cochlea. This structure here, this is the saccule and this is the utricle. These two are important for you to remember, for you to know what is the position of your head. Okay? And then here in this structure, you have what's called the semicircular canals. And the semicircular canals have like, it's like a XY, XY, and Z axis. So it's a 3D structure that gives you the sensation and the spatial notion in 3D, right? What is important for us to know about the semicircular canals? There is a structure inside the semicircular canal that is called crista ampullaris. Crista ampullaris is filled with little rocks, and these little rocks that are called otoliths, they will help to give you the response to angular rotational movements of your head. Okay, so when you spin, you're using this organ to give you the idea that you are spinning. And when you stop spinning, because these structures are still moving, you still feel dizzy, right? I think we're ready to talk about the cochlea. So the cochlea is a small, spiral, conical, bony chamber the size of a split pea. It's really small. That's why it fits inside your temporal bone. There are three main parts of the cochlea: the scala vestibules, the scala mediae, and the scala tympani. It's a little hard to understand this, but let's try together. So this is the snail, the cochlea, right? That looks like a snail. If you cut a slice here, you're seeing the inside of it. You see how you're cutting one piece here and one piece here and taking all this whole piece out? So you're taking like a slice out so you can see what's inside. So you have the vestibular membrane here, the cochlear duct, which is the middle part, and then these two external parts are the ones filled with perilymph. Their names are not here, but what's important is that you're gonna hear in this middle one. See, you can see the same structure here. This is the structure that you're gonna actually use for hearing. This is where the sound travels to reach this middle structure, which is the cochlear duct, is the scala media. So these lateral tubes, they're like tubes, right? Because think about this snail. Try to unroll it. I'm going to show a picture of it unrolled. You're going to understand how this is all like one tube that is rolled around itself. So the other two structures, this and this, are the scala vestibuli and the scala tympani. Okay, and the scala media is the one where we hear, that has our hair cells. This picture is better. So looking at just one of those tubes, you can see that not one of those tubes, one slice of that tube, you can see the scala vestibuli with the perilymph, scala tympani also with perilymph. This is where there is endolymph. This is the cochlear duct, right? And here inside the cochlear duct, you have a little part that is called spiral organ. Spiral organ, or organ di Corti, is the region where you have the little hair cells, and they feel this vibration that comes from the sound, because the sound vibrates all the structures inside your ear, and that's what makes you hear. That vibration is sensed by the spiral ganglion, that is already the ganglion from the cochlear nerve, and that's how you hear. Higher frequencies are heard usually in this area. Lower frequencies are usually heard in further away. If the frequency is too high or too low, we don't hear, right? So what happens is that when the frequency is too high or too low, you're not going to be able to reach the membranes inside the cochlear duct. And then the sound just vibrates in these two lateral channels, and it goes around, and it goes around, and it comes back. So this vibration does not reach the cochlear duct. When the frequency is between, what do we hear? Between 1500 and it's around 600 to 1500. That's the middle frequency that we are allowed to hear, right? Because of our organ. So then you're able to hear the sound. This is just a table showing you the semicircular canals have the crista ampullaris, that's the receptor region. The vestibule that makes you able to know the position of your head. How do you know you are sitting, or if you're laying down, how do you know you're laying down? Because of the position of your head that is controlled by the vestibule. So this is for static position. And then the spiral organ, which is the receptor for the cochlea. There is a nice video here about physiology of hearing. I would watch it because it's more dynamic and it shows you all this as it's happening. Okay? We're done. Thank you for your attention. Thank you for being here and taking this course serious. I hope you guys do great in the final exam. And please let me know if you have any questions, okay? Bye-bye.